Hey everyone, welcome back to our YouTube channel. In today's video, we'll be seeing the solution for the first problem statement of division 2, that is pieces of clothing. So let's understand the problem statement at first. We are given with two numbers, that is P and Q, which essentially denotes the minimum and maximum possible length for a rectangular piece of clothing. Now we are given with abundant number of pieces, out of which we have to determine the minimum and maximum number of pieces which has to be selected so that when they are connected together or when they are joined together, we'll get a long piece which has length of around z kilometers. Now, if such set is possible, then we'll output those minimum and maximum value of the number of pieces, else we'll output -1. So let's see how we could solve this particular problem. So as the problem statement suggests, for a single piece of clothing, the minimum length could be P, while the maximum length could be Q. Now let's assume that I have n number of such rectangular pieces of clothing. So after connecting all of these n number of pieces, the minimum length that I can achieve out of them is np. So the justification for the same could be all of these n pieces could have the minimum possible length, that is p, so n into p. Similarly, the maximum possible length that I can achieve out of these n pieces only is n into q, because q could be the maximum possible value for the length of a single rectangular piece of clothing. Now, if we would consider any intermediate case, let's say out of these n number of pieces, only one has length equals to p, while I'll write down the plus symbol, then the remaining are n minus 1, so we'll write down n minus 1, n minus 1, and let's assume that they have the length equals to x, let's say. So by default, x will lie in between p and q only, because this is the range for the values of the length of the rectangular piece. So essentially, this value that we get lies within this range only. Thus, we could summarize that the z kilometers length that we want to obtain would be between np to nq. So np will be the minimum limit and nq will be the maximum limit possible for z. Now, if we look at the constraints, so it suggests that the minimum value that p or q can have is 1 meter, while if we look at the z value, so the maximum value for z could be 10 to the power 3 kilometers. Now, if we would convert it into meters, so we could have that equals to 10 to the power 6 in meters. So obviously we could iterate over this particular range. So the brute force solution that we could generate for this particular problem will include iterating over this range starting from 1 till up to 10 to the power 6, and we'll simply check out this particular condition, that is whether my z lies in between np to nq, that is ip to iq, considering I as the iterating variable. We'll check this condition and accordingly we'll proceed. So let's take a look at the code. Within the code, at first I've initialized INF to a certain maximum value. Now this value that we are specifying over here is essentially equals to 2 to the power 29, which is quite a maximum value, and I'm using the left shift operator for the same. Now if we take a look at the input format, so we are given with three numbers P, Q and Z. So we'll be taking the input in that particular format itself. Now I'm initializing them to int because essentially, as the constraints specifies, we could have them within the integer values range. So we'll be taking these p, q and z values as input, after which, as mentioned, p and q are in meters while z is in kilometers. So we'll be converting z to meters. Now we'll be multiplying it with 10 to the power 3, which is done over here. After which, I'll be having two different variables, which are answer max, which essentially indicates the maximum number of rectangular pieces to be chosen, so that after joining them, so we can get z kilometers length rectangular piece. And answer min essentially indicates the minimum possible number of rectangular pieces to be chosen, so that after joining them together, we'll again get a piece of z length itself. Now, I'm initializing the maximum value to a certain minimum value, which is -1, and the minimum value is initially assigned to a certain maximum value, which is INF, which is 2 to the power 29. Again, I'm having a flag variable, that is found, which is initialized to 0, which indicates whether we found the answer or not, because if we didn't found the answer, we are supposed to output -1 as well. Now I'll be iterating over the possible values as discussed within the approach. So the possible range of values are from 1 till up to z, and the maximum value that z could have is 10 to the power 6 in meters. as specified by the constraints. And it's obviously possible for us to iterate over that particular range. So after iterating over the range from 1 to up to z, we are incrementing the I value, and then we are simply checking the condition that we have specified over there. That is, that z value which we want essentially should lie between np and nk. So here n will be replaced by I itself. So after having I number of pieces, the minimum possible length that I can construct out of these I number of pieces is I into p, and the maximum possible length that could be made out of these I number of pieces after joining them together is I into q. So we are checking whether z lies between this range or not. If it lies within this particular range, then we'll be updating our answer values. That is, maximum value will be updated by the maximum of the previous answer max value, and the number of rectangular pieces that we have selected for this particular iteration. Similarly, we'll be taking the minimum out of the previous value of answer min or the I value for the current iteration, as I indicates the number of rectangular pieces to be chosen. Now again, found will be initialized to 1 because we at least found a certain answer, right? Once we come out of this particular for loop, then we'll be checking whether we found the answer. If we found the answer, we'll output the minimum number of rectangular pieces chosen and the maximum number of rectangular pieces of clothing chosen. Else, we'll output -1 if we didn't found any answer. And this is how we could actually go by the approach discussed. So let's run the code. Yeah, it's passing all the test cases. If I try to submit it, it's getting accepted for all the test cases which are there. So thank you for watching.